Hey guys, welcome to Deep Dive Coding. Today we solve the LeetCode problem of the day, that is sort vowels in a string. So at the end of the day you will learn how to solve this problem, as well as I will show the two approaches and discuss their time complexity and space complexity. So we will learn how to solve this problem and how to optimize further. Without further delay, let's start the video. And problem is basically says that we are given a string s that is consist of the consonant and vowel. We do not touch the consonant indexes and consonant positions, and we are only going to do that whatever vowel positions is given. We take all those vowel positions and sort them by the ASCII characters and replace their indexes correspondingly. Like let's say we have three vowels. We have three vowels, that is v1, v2 and v3, and that is right now in the index. v1 is located at the I1 index, v2 is located at the I2 index, and v3 is located at the I3 index. So what we have to do, that we sort the vowel v1, v2, v3 by their ASCII characters. Each and every characters have their ASCII characters, ASCII value. It's not ASCII characters, it's ASCII value, and place them in the I1, I2 and I3 indexes in the sorted order. Let's say uh, after sorting, we get that v2 first, then v3, and at last v1. So what we place that, and we know that I1 is less than I2, maybe, yeah, I1 less than I2 and I3. We know this thing. Now what we do, that we have the array that is string is given, so we place I1 positions, that is v2, because v2 will be the first character, that is vowel, that is the smallest one according to ASCII value, and s of I2, that is I2 index, we place the v3, and at the I1 index, not I1, that's I1, I2 and I3 index, that will we place the vowel v1. Now you understand this problem. Now if you think this is a simple problem, like it is fairly simple, let's write the code and you will able to understand it. So what we do, that we first take the unordered set to effectively look up the which character, whether it is vowel or not. So we can say that this is the vowel, and we have first of all we place them small value, that is I, whatever it is, you can go with even larger value, capital value also first. Okay, so a I o u, and again capital 1, that is capital A, capital E, capital I, and O, and capital U finally. Now this is the whether we store the all the vowels which may present. So question over here, it's given that yes consist only of letters of English alphabet in uppercase as well as lowercase. Now we can't, let's say we discuss about the brute force approach. Fairly first brute force approach, we take a string of, let's say, temporary string. We are only storing the vowel, so we iterate over the main string, like equal to 0, I less than s dot length I plus plus, and if vowel dot count s of I, that means current si is it vowel or not. If it is vowel, then we simply append that characters in the temporary string, that is s of I. After these things done, we sort by the ASCII value, and that can be done by simple sort functions in the C++, that is temp dot begin and temp dot end. Now here is the thing, like yes, we sort that array. Now we take an index, like vowel index, that is j, let's say that is 0, and we again iterate over the string I equal to 0, I less than s dot length and I plus plus. So we again check that whether it is vowel or not. That can be done similar way, that vowel dot count, we look into that set whether it is present that characters, then it will be the vowel. So it will be the vowel. Now what we'll do, that we have the temp string that is already sorted by the ASCII value. So we simply iterate over the temp array like temp string, and we increase that counter so that it will place the sorted order. So s of I equal to temp of k, not k, that will be the vowel index, and that will be the plus plus. And at the end we simply return the string s. Okay, so now let's run it on the code. It's saying something is wrong. Okay, it's spelling mistake. Ordered, unordered set. Yeah, it's run for the sample test case. Now let's discuss the time complexity, how much it is optimized code. We are storing over here like a set, and over here we are iterating through the string dot length, so it will take the big of n time complexity, and we are looking over each characters in the unordered set, so it will take amortize big of one time complexity. Amortize means that most of the time it will take the big of one time complexity. At the worst scenario, uh, if hashing is collision is occurred, collision is occurred in hash function, then it will take the big of n time complexity. But you can say that it will almost always take the big of one time complexity. And after that there is sorting is happening. The sorting is take the n log n time complexity, but you can say that as we are storing that in the temp array, we are storing the vowel only. So if we say that there is number of vowel, let's say number of vowels equal to v, then it will take big of v, and it will again take the big of n time complexity. It will take amortized big of one time complexity to look up, and so total time complexity would be big of n for here, big of v and big of n. So big of v plus big of 2n time complexity. So you can say that at the worst scenario, each and every characters in the string s is the vowel. So then in that case the temp array will be the simple s array in the sorted format. So big of v so can go at worst scenario big of n. So you can say that this will be the big of 3n time complexity, and you can say that will effectively big of n complexity. And if we discuss about the space, then we are taking only the unordered set, that will be the that will take the 10 space for storing the character. Apart from that, we are using that temp array for the storing that vowel. So you can say that this will take also big of n time complexity, because we are temp array can go at worst scenario big of n. So this will be the like brute force approach. We can further optimize it by observing something like, and if you look into this, that we are only dealing with the vowels, that will be the 10 vowels, 5 is small and 5 is capital. So instead of we are doing that temp array in the full, like temp array can be look like this way, that we are taking that like a is, let's say occur is 4 times, e occur is 3 times, and ii, and this way. So instead of doing whole this 4a and 3e and I, we can use the vector for vector of 10 character, like 10 space, and there we will store the all the value of the vowels, how many occurs that things. Like I will show you. Let's say it will be, let's remove this one. Let's first run this code first, whether it is accepted or not. Let's run it. It's accepted for the sample test case. Now run for the, now submit it. Yeah, it's accepted. Now let's go through the optimized approach. This is brute force one. Optimized approach. Now we will look similarly. This will stay there, but we remove this one, and we remove this string, and we remove this one as well. We do not sort it so that it time complexity is be reduced. Okay, so over here I have done some mistake. It will take the big of log v log v, so it will take time complexity of big of v log v and plus big of 2n. That will be 2n plus, at the worst scenario it's n log n, and that will eventually n log n time complexity. Okay, so it will be the n log n time complexity, and we reduce down further the big of n time complexity by removing this sort function. So we remove this sort function as well. We are not iterating through this. Now what we can take, that we are taking that vector of int that will count the how many vowels for each, like that will take the take the space of the 10 characters, and each count is 0. So what we'll take that, let's first 5 character, first 5 space for small, like lowercase alphabet alpha, and next 5 will be for uppercase. Okay. So over here we know that this will be the vowel, so we increase that vowel in the count vowel and get vowel index by the character, that is s of I, and we increase that count. Okay, we will define these functions as well. Now over here what we do, so it will go through the vowel index, that is fine, but if count vowel of get vowel index of s of I, if it is if it is equal to 0, that means it's not until it's 0 we count, like we increase that thing. Wait, it will not be this way. So it will be the vowel of index until it will be until it's 0 we increase that, because we want to place that vowel which is present in the string s. So now we update that, like s of I index, at the ith index we, let's get vowel by the index, that means v of index, and we decrease the count by 1 because we already use it, vowel of index minus. Yeah, so now we define the two functions. One is get vowel index and another one is get vowel. Okay, so it will be private int get vowel index. It will take the character, that is ch, and we define a switch statement, that will be switch. Now we define each case, let's say first a, that will, for that return first index, that will be 0. Let me copy this thing, and then it will be it will be e, and return one index I, that will be that 02 index for the uppercase. First we are taking all the uppercases, and u, a I o u. Yeah. So it will back the fourth index. Now this will be the for small, that will remove that will return the 5 A E I O and U. Okay. Now it will return 6th, this one is 7th and 8th, and finally this one. It will return that index. If it is not, by chance it will come in there, then we can say that it's not valid index, that will be written by -1. Now another function is that will return the characters, and that will give the vowel by the index. So it will take the int as index, and let's say first a string of vowel, that will be A E I O U and A E I O U, A E I O U, yeah. So it will return simply vowels of index. Okay, now let's see whether it's fine. Let's try for the sample test case. It's not reached. While count will be the count of that position is 0, we are increasing that count because we are, so that we can get the non-zero, like present in the vowel, that string. Now let's try for it. Yeah, it's accepted for the sample test case. Now it's submit it, and I will discuss the time complexity of it. Yeah, it's accepted. Now let's discuss the time complexity, what it's improved. So over here we take the count vol of size 10, and this will again added to the big of in, it will take the amortized, and it will also take the big of n, and also it's amortized of this thing, and this while loop it's take at max the count of vol, like count of vol is 10, but it will take at most big of n. So you can say that this time complexity is reduced down, and it will take the big of 2n. You can say that that will be the big of n time complexity. Now it's improved from the previous one, because that one is big of n log n, but now it's big of n, as well as there is also improved the space complexity. Like we are using the constant space for the unordered set, we are using 10 space, and for the count vol we also use the 10 space, so it will be the constant space, so that will also increase that. So you can say that big of 1 space complexity. Now it will be the optimized approach from the previous one. And yeah, thank you guys, thank you for watching, and if you found this video is helpful, please comment the below whether you have able to submit it or not.